Hey gang, thanks for tuning in. We're doing a Mohr's circle slash stress transformation slash combined load problem. I know what you're saying. Dr. Hanson, why are you doing another Mohr's circle, another combined load? Because I care about you. And I know that you're really bad at these, okay? And we need lots of practice on combined loads and Mohr's circle. So here we go, okay? Let's see what we got. What do we have? You left for college. Your mom and dad said, hey, we don't need this big old house. They put a for sale sign in your front yard. And that's not nice. Okay, no, maybe it's a for sale sign in somebody's yard. And what's it got on it? It's got a 300 Newton load pulling this way. And it's got a 350 Newton meter torque there, if you will, a moment on the end of it there. And they say over here on this plane right here, 1 meter off the ground, there's a point A. And point A lives at this spot right there on the cross section. This is like a blow up cross section of that right there, okay? And they say, what are the stresses, the principal stresses at point A? Also, what is the maximum? And it says absolute. That word is important. And if you don't understand that absolute, check out the next video that says, I think it's 2 videos away. It says how to find absolute shear stress. That's a really good definition and explanation of what that is. But we're going to find it here as well. So find the principal stresses and the shear stress at point A. So that sounds like more circle kind of stuff. But in order to find that, we need to go, we got to do the combined load. We got to come up with what's a stress element at point A look like, okay? So all that we're going to be after is this guy, is a stress element. What does that look like, right? Does it have sigma stress on it? Does it have tau stress on it? Okay? We got to find that stuff out for point A, okay? Because remember, A force can cause lots of different things. It can cause P over A stress, MC over I stress, right? That's normal stress. But it can also cause VQ over IT, transverse shear stress, or it can cause TC over J, torsional shear stress, okay? Now in this one, we don't have any torsional shear stress. It's a 2D problem. And so we're not going to have that, okay? So what do we do first, okay? You know what I think the first thing you got to do is? I think we just chop this sucker in half right here, at point A, and we find out what's going on inside the beam there at point A, okay? Because what you got is this. Okay, there's the beam. Here's the loads. 300 newtons and 350 Newton meters. And then what happens at point A where I cut the beam? Because every time you cut the beam, you must have a MNV. Okay, right? We've got an N, we've got a V, and we've got an M. Okay? So let's see if we can find those things. Now I think I'm gonna move this arrow here. I'm gonna put the arrow that way. Why are you putting the arrow that way? Because that one goes, I think the 300 is pulling me this way. Then this V has to go that way, right? And right off the bat, I see this, right? V is equal to 300 newtons. Is that true? How did you do that so fast? Just the sum of the force in the X. That's the one in the X, and that's in the X. If we do the sum of the force in the Y, what do we get? I got N. That's it. So N is equal to 0. What does that mean? That means that there's no P over A stress. There's nobody pulling or pushing me in that direction, isn't there? Okay? What else? All right, let's see. What about M? Can we get M right quick? Sure. Take the moment about, let's call it CUT, the moment about the cut. Okay? And what do I have? I drew that moment positive. It's just an assumed direction, isn't it? So I'm going to put him in there, M, and then I've got the 300, which rotates me what? Negative, right? So minus 300, times how far away? So from point A, up to where the 300 is 2 meters. Okay? And we assume that this really and truly, this goes to right here. So it's not half the width of that beam. We don't know what the width of that beam is. Okay? And then is there anybody else that's causing moment? Oh, look, there's a burrito force there, huh? 350, and he's rotating me. That's positive, so just plus 350, right? Johnny Weeksauce would say, how far away, and try and get a distance with that, but hey, it's a burrito. All the good stuff is already in there. It's got newtons and force and distance, doesn't it? Okay, so M is equal to, let's move that to the other side, 600 minus 350, which means that M is equal to 250, what? Newton meters, right? And the 250 is positive, which means that my moment is going, counterclockwise, right? Okay? So, do we have any N over A stress? Do we have anything in this direction that's causing a compression or a tension? No, we don't, right? Because N is equal to 0. So we've got to tend to this guy that sigma equals MC over I. Now let's think about M first, okay? So here we've got sigma. We got to tend to that M. What is M going to be? Well, I know what M's going to be. It's going to be 250. But let's think about which way that 250 bends, right? The 350 bends me this way, right? Bends the whole thing like that. But this guy is 300 times 2, so he's 600 Newton meters, right? As far as the torque goes. 600 is bigger than 350, right? And it's trying to rotate me that way, right? So the net of those two moments added together is a moment that's doing that, right? Now look where point A is. On my cross section, my neutral axis would be here because I'm bending in this direction here, right? I'm bending around this axis. This is the neutral axis, okay? And so A is on that side of the neutral axis. Remember, if I'm bending this way, then this side of the beam, right, over here, is going to be in tension, and that side is going to be in compression. So sigma is going to be what? Negative. That's what the compression's for, right? And then 250 Newton meters, okay, times C. What is C? C is the distance from the neutral axis to the point of interest. So the neutral axis is here. The point of interest is there. Now if it's 50, let's see, the whole thing is 150, so half the part must be 75, huh? So if from the end of the part to A is 50, then from the neutral axis to A must be 25 mm's, okay? Now, don't forget, that guy there is in meters. We need that meters gone. So let's put a meter on the bottom. That's 1,000 millimeters. Now my meters cancel out. I feel good again, okay? And now down here on the bottom, what do we need? We need I. We need I. We got to calculate, well, it's just a rectangle, right? I equals 1/12 the base, okay? Now, Johnny Weeksauce would say, hey, the base is 150. No, because we're doing this, right? We're doing I, Y, Y, okay? So everything is on the side. So what used to be the base is now the height. What used to be the height is now the base, right? So the base is actually 50. The height is 150 cubed, 112 BH cubed. Or if you want to do it the way the book does it, 112 HB cubed, right? For IYY. Now that's it. Do we have to do the parallel axis theorem? No, because the centroid is on the neutral axis. We don't have to do that here. You can do it if you want, but D is going to be equal to 0. Okay, so here we go. So what do we get? 50 times 150 cubed is equal to big number divided by 12 equals. Okay, here we go. This is a big number. Here's what I got. 1406 2500. What is that? That's millimeters to the fourth. Are you scared of big numbers? I'm not scared of big numbers. My calculator doesn't seem scared of it. Here we go. 250, right, times 25 times 1,000, and then I'm going to put divided by answer, right? That giant answer I had. Boom. Sigma equals 0.444, and then what is that? That's newtons over millimeters squared, which is equal to, what is millimeters, newtons over millimeters squared? That's a megapascal, isn't it? Okay? So, in other words, point A is being compressed. If I'm a little piece of material at point A, I'm being squeezed together because of beam bending, right? So I look like this, boink, boink, right? There I am being squeezed together, and I am 0.444 megapascals. Okay? Now, how much force do I have that's squeezing me in this direction? Do I have any P over A or MC over I in this direction? No. Matter of fact, sigma x here is equal to 0. 0, okay? Next thing, we need to figure out this guy. What is causing me shear stress? Who causes shear stress? That dadgum V causes shear stress, doesn't he? So V is 300. Here, let's get this guy out of the way. So tau. Now again, there's two kinds of shear stress. You got this kind, tau equals VQ over IT, transverse shear, but you also got this kind, tau equals TC over J. That's from torsion, but we don't have any torsion in this problem. All we have is transverse shear, okay? So we're going to do the VQ over IT. So V is 300 newtons. Okay, times Q. Oh, we love Q, don't we? Come on, Q's not that bad. All right, what is Q for this? You ready? Push pause and get Q right quick. Go. All right, are you back? Let's see if you get what I get here. Q goes like this. Q is, remember, from the point of interest all the way to the outside of the part. That's Q. So here it is. All of this out here is Q. And Q is Y times A, okay? And Y bar is the distance from the neutral axis to the centroid of that area there, okay? Well, from the neutral axis to the centroid there, that's 50, isn't it? Times that area there, which is 50 by 50, isn't it? So it's 50 times 50 times 50. Okay? So Q is 50 cubed. 50 cubed. Millimeters cubed. Okay? Are you with me on that? Did you get it? All right. Okay, divided by I. Oh, we already have I, don't we? VQ over IT. I is 1/4, same I as we had up here, right? 0.62. 500 millimeters to the fourth, woo, that's big, times T. What is T? Just think about T as being the thickness that I have to tear through to get that area there to move what? To tear off. Well, I'd have to tear through this thickness right there, wouldn't I? And the answer is 50. Okay? So guess what? That 50 and one of those 50s will go away. That'll just make that a square up there, right? So what do we have? 300 times 50 squared equals, divided by 14062, 500 equals, 0.0533 newtons over millimeters squared. Okay, because the millimeter squared and the millimeters to the fourth gives me millimeter squared on the bottom, doesn't it? So tau is 0.0533 megapascals. Okay, yikes. Okay, now here's another little quickie thing I'm going to tell you, another little secret of the pros. Okay, how do you find which way tau goes? Do I draw it like that? Right? Or do I draw it like that? I don't know. How do you tell? I'm going to show you how to tell, right? Here's the way I think about this. Let me get rid of all of this. okay? And I'm going to go ahead and get rid of this too, okay? Just so it's out of my way. Now this little free body that I drew was, I cut that beam in half at point A. So imagine I cut it in half at point A, but here is point A. Here's the little piece of material, right? I got this piece, and then I got this piece down here on the bottom, okay? Where it goes into the ground. But that right there is my little stress element. There's point A. So what do I have? Up here I have a shear of 300 going that way. So here I have to have what? For equilibrium. I have to have a V going that way. So what is it on my little element there? This way on the bottom. This way on this guy. That way. And then in the ground down here, if I ever find out equilibrium for the ground, it's got to go that way, doesn't it? Okay? And that tells me which way my shear goes on this guy. Does that make sense? I think it's a super easy way to do that. Okay? How's that? Ba-bam. Okay? Now, all of that was last chapter, level 8. It was combined load stuff, right? So we used combined load stuff to come up with the stress element. Now that we have a stress element, I think we can answer that question over there. Let me erase my board. All right, so from this guy, we're going to do Mohr circle now. We need, our first thing we do for Mohr circle, get our 2 coordinate points, right? So we need our X face, this is the X, then we need our Y face, okay? Here we go. So from the X face, I have what? 0, and then what? I have that much stress on the X face. Which way is it going? Counterclockwise. Doesn't it rotate me counterclockwise? Which is a positive, right? So 0.0533. And then on the Y face, oh, it's negative 0.444. And then over here, negative 0.0533. And again, those are all in megapascals, aren't they? So let's plot this, shall we? And now what we can do to make this a little bit easier, maybe, instead of putting this in megapascals, can we move it to maybe kilopascals? Which would be move the decimal over 3 places, right? Right, so 444, whoa. And then this guy would just move over to what, 53.3? Right? Negative 53.3. And that's in, these are all in kilopascals now. Is that better? You don't like working with decimals that much? If it freaks you out, we'll be in kilopascals now, okay? No big deal. All right, here we go. Sigma stress, tau stress. Oh, and what is up? That's the negative. Tau down here, that's the positive, okay? And of course our sigma, this is our positive sigma over here. So here we go. Let's see what we got. Oh, we got some big numbers here, negatives, don't we? So, let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. You could measure those with a ruler and they would be perfectly spaced. Look at that. It's just amazing, isn't it? I know. Keep your seat. Keep your seat. This is a little bit of a oversell there. Okay, let's plot these points. This guy right here is 0 and positive 53. So here's 0 and then positive 53. Let's say this is 50, 25, 50, and then 3 is right here, okay? So there's point 1. So that's 0, comma 53.3. And then the next one is negative 444. Uh-oh. 100, 200, 300, 450, 444, and negative 53, something like that, right? And that guy right there is negative 444 and 53.3, okay? So connect the 2 dots, okay? Make yourself a big giant circle, okay? Something like that, right? Zoop. Is that a bad circle? Is that a good circle? It's not the worst circle I've ever drawn, but you know, it's not great, but don't be so hard on that guy. Okay. Here we go. What do we do first? Find the center point of the circle. Well, if this is 0 and that's negative 4, 4, 4, the center is at negative 2, 2, 2. Okay? So then what? Make myself a little triangle here. Calculate the radius. The radius is going to be 2, 2, 2 squared plus this height here, 53.3 squared, square root. Okay, that's the radius, which is, I can't do that one in my head, folks. I just can't do it. Here we go. 222 squared plus 53.3 squared equals inverse square root, inverse answer equals 228.3. Okay, kilopascals. Now what is that right there? That's a radius, but what does the radius of the circle represent? Remember, this is a radius also. So what does the radius represent? It represents tau max. Hey, we just found tau max. Is it tau absolute max? Is it absolute? The answer is yes. How do I know the answer is yes? Because this circle goes on the other side of 0, right? If the circles, the Mohr circle straddles this axis, right? If these 2 points, sigma 1 and sigma 2, if one of them's positive, one of them's negative, then that circle is going to have the absolute every single time. Did you get that? Listen to that one more time. If sigma 1 is positive and sigma 2 is negative, then that Mohr circle is going to contain the absolute max shear stress every single time. Ooh, I might write that down in my notes. That was a good one right there, Hanson. Pro tip of the day, okay? And you didn't even have to pay anything for that. Is that cool or what? Okay, now how do I find these two things, the principal stresses? We found that guy. We got him. Check mark. We need those first two guys. Sigma 1 and sigma 2 are equal to the center point, right, which is negative 2, 2, 2, okay, plus or minus the radius, right? Because one radius gets me over to here, the other radius gets me over to there, right? That's where sigma 1 and sigma 2 are. Those are our principal stresses. So 228.3. So sigma 1 is equal to what? 228.3 minus 222 equals 6.31. 6.31 kilopascals. Whoop, that's it. Sigma 2, what's sigma 2? Negative 222 minus 228.3 equals negative 450.3 kilopascals. What do you think, gang? That's it. We answered all the questions. We found the principal stress. We found the absolute maximum shear stress. We did Mohr circle. We did combined loads. We did it all. All right. Does this help? All right. I hope this is a good review. Hope you make 100 on your next test. See you on the next video.